This is chapter 3, number 40, extra credit problem. The problem is number 40. The problem is, suppose a Chinook salmon needs to jump a waterfall that is 1.50 meters high. If the fish starts from a distance 1.00 meters from the base of the ledge over which the waterfall flows, find the x and y components of the initial velocity that the salmon would need to just reach the ledge at the top of its trajectory. Can the fish make the jump? And the fastest speed that a Chinook salmon can jump out of the water is 6.26 meters per second. So I'm gonna write down all the information. So first I'm gonna make a sketch. Here. So here's the salmon. It is 1 meter exactly away from the waterfall, from where the waterfall is, and the waterfall is 1.5 meters high. So the salmon has to make this. He has to make this jump to where we have to find what will the x and y components of velocity be where it just makes the jump. So that means that it will be at the point 1 and 1 comma 1.5 at the apex of its height. So the total jump is gonna be this: A, B at the top, and then C at the bottom. But because we only need to know how fast it's gonna go to get to B, and we only really need to know about B since we don't really care what happens after it gets over the waterfall, I'm just gonna ignore this and use only half. So for A to B, these are the givens and then the unknowns. So we need to find the velocity. That's going to be our answer, is going to be the velocity, the initial velocity, the final velocity, and the only final velocity we know. We know that x's final velocity is going to be the same, but y's final velocity is going to be 0 meters per second because it's at the apex of its height. We know the acceleration for both, and since it's jumping in the air, it's going to be 0 meters per second for x, and because there's gravity, it's going to be negative 9.8 meters a second squared for y, because I'm having this way be positive. So positive y. And, yeah. And so change in x, this is going to be 1 meter, and this is going to be 1.5 meters, which you see here. And then time is also an unknown. So first I'm gonna find time. First I'm gonna find the initial velocity of y, since we have three givens in y, so we can find it. So here, so vi of y, and since we don't have time, we have to use the equation without time, which is final velocity squared is equal to initial velocity squared plus 2 times acceleration multiplied by the total distance covered. So we have 0 meters a second squared is equal to initial velocity squared plus 2 times negative 9.8 meters a second squared times 1.5 meters. So now we're going to have initial velocity squared is going to be equal to, so multiply this, multiply this, 2 times 9.8 times 1.5 is 29.4. So now we know that this is negative 29.4 meters squared over second squared, and so we bring it to this side, and then we flip it around so that vi squared is on the left. And then we have vi squared is equal to 29.4 meters squared over second squared. And so then take the square root of both sides to get what the initial velocity of y is. And then the square root of 29.4 is 5.4. This is 5.42. So VI is equal to 5.42 meters a second. So now we're going to want to find time, since time is going to be the same for both x and y, and that'll get us our third given for x so that we can find the initial velocity for x. So now that we have this, we can write this in. Okay, so now we need time, and I'm going to use the first equation since it's the easiest and it has time in it, which is, VF is equal to VI plus AT. So 0 meters per second is equal to 5.42 meters a second plus negative 9.8 meters a second squared times time. So then we'll have time is equal to negative 5.42 meters a second over negative 9.8 meters a second squared. And so if you use the units, the meters will cancel each other out, and since they're both being divided by seconds, then it'll flip and it'll end up being seconds squared over seconds, so then you'll get seconds, just normal seconds. So t is equal to it's going to be negative 5.42 over negative 9.8 seconds. So negative 5.42 divided by negative 9.8 is equal to 0.55. So now we know that the seconds seconds total until it reaches the apex of its height is 0.55 seconds. So we write it in here, 0.55 seconds, and since the time is going to be it's going to be for both, since they're both being at the same time, it's 0.55 seconds for the x too. And so now, this is solving for time. And then now we need to find the initial velocity of x. So VI of x. And so we don't have the final velocity, so we're going to have to use the equation delta x is equal to initial velocity times time plus 1/2 acceleration times squared. So we have everything in there except for initial velocity. So we're going to end up having 1 meter is equal to initial velocity times 0.55 seconds. And then that added to 1/2 times 0 meters per second squared times 0.55 seconds squared. So because this is a 0, then you just negate all this because it'll become a 0. So that means that initial velocity is going to equal 1 meter over 0.55 seconds. And so put that into the calculator. 1 divided by 0.55 is equal to 1.81 repeating. So round that to 1.82 meters a second. And so now you have your x and y components of the initial velocity, since 0.82 meters a second. So now the x component is this, the initial velocity of x, so the exponent of the velocity is equal to 1.82 meters a second. And then the y component, which we found here for the initial velocity of y, is equal to 5.42 meters a second. So that's to barely just get over the top, to reach the apex at the top of the waterfall to get over it. You need this x component and this y component to barely do it. So now they want us to find out if it's possible for the salmon to actually do that. So they gave us earlier, if you look at the question, it'll say that a Chinook salmon can jump out of the water with a speed of 6.26 meters a second. So that means that the velocity total has to be less than or equal to has to be less than or equal to 6.26 meters a second. So here, it's not to scale, but 1.82 meters a second. So this is the x, this is the y, and then this is the velocity, the total initial velocity. And so this is the y, which is 5.42 meters a second. And so using the Pythagorean theorem, since this is a right angle, you know that the velocity will equal 1.82 meters a second squared plus 5.42 meters a second squared. And so you do this on the calculator. (1.82 squared plus 5.42 squared), and you get 32.6888. So that is 32.6888 meters squared per second squared. Oh, I'm sorry. The Pythagorean theorem has the initial velocity squared also. So, and then you take the square root of both sides. And then you get that the initial velocity for barely just getting over is 5.72 meters per second. So, and then because 5.72 meters a second is less than 6.26 meters a second, therefore, the salmon can make the jump. And that is question number 40.